All right, so looking back from the graph to the equation, your solutions are your x-intercepts. So thinking about why does that make sense? Here you have y equals, here you have 0 equals. What is the what is this line right here, your x-axis? That's what? Y equals 0. So think about that y equals 0. That's your x-axis. So where your graph is crossing your x-axis, that's your solution of when it's equal to what? 0. So it's kind of thinking about that y equals 0, that idea of like y equals or 0 equals, kind of the same idea whether you're looking at it from a graph or an equation. So kind of looking at question 2, if you were to solve this, you would have x squared is equal to 4. And what would we know x should equal from here?
Plus or minus.
Yeah, that idea of the plus or minus 2. Because when you're taking your square root, anytime you physically are drawing in your square root to solve, like I just did, that's when you have that plus or minus. Because that positive 2 squared, think about positive 2 squared would be 4. 4 minus 4 would give us 0. Negative 2 squared would be 4. Minus 4 would also give us 0. So once again, what do we notice? Our solutions are the x-intercepts. Good. So based off of question 3, what can you already predict? Okay, so we're going to transform our thinking. If I was before today, before last class, Charlie, can you stop the humming? Thank you. I would have just said that there's no solution, but now it's going to be no real solution. So you are going to have a solution, but what are we predicting our solution might be? Imaginary, right. Good. So thinking about here, I would have x squared is equal to a negative 4, and then what am I doing to solve for x? Square rooting. When I square root, I have plus or minus. So x would be equal to plus or minus what? 2i, right. So remember, this means when you're not touching your x-axis, that means not just no solution, but no real solution. Because our solutions are imaginary values here. So let's look at 2 of these together. It doesn't matter which 2. We can look at number 4 first, and then one of the squared quadratics. So I have the absolute value of y minus 4. How does that shift my graph? We go where? To the right 4. So that vertex point is right here at 4, 0. So already looking at my graph, I can predict I'll have how many solutions? Yeah, I can already see I will have one solution, because why?
It only hits the x-axis.
Good, it only hits the x-axis once. So think about why that makes sense if I'm solving. I have the absolute value by myself, or by itself, and then I think about what are those 2 equations I'm making. I'm making x minus 4 equal to plus 0 and minus 0, which is the same thing. So we know x should only be equal to 4, which makes sense based off our graph. So let's pick either 5 or 6. Does anybody have a preference? Let's do 6 because it goes the other way. So 6, we are going to be transformed. How graphically? If I have x plus 4 squared, where's my graph shifted? Left 4. So I'm squared, that U-shaped graph. So I'm still going to predict I'll have how many solutions? 1 solution. So think about once again here, something is squared. How are we solving for it? We're taking the square root. And when I take the square root, I want what in front of it? Plus or minus. But does it matter here? What's positive square root of 0? 0. What's negative square root of 0? 0. So this is just 0 is equal to x plus 4. So we know x is just really equal to -4. Here you should have gone x equaling 4. The quadratic here. All right, so let's kind of go dive a little bit deeper into this, but always remembering those connections about how your solutions are your what? X-intercepts. Good. So let's first talk about your square root method. So you're using your square root method on like problems we just did, right? We solved and we were solving by physically taking the square root. So you're going to do this whenever you just have an x squared or like a binomial, so like x plus or minus some type of number squared. So this method is only used when you have no bx term. So no like x term, just that x squared term. And kind of your first idea, like we just did in a few of those problems before, would be to isolate that first. So isolate the x squared, that x plus or minus whatever number, that binomial squared first. So let's check out question 1. Thinking that I'm getting that x squared by itself first. So what would our first step be just to get that x squared by itself? Yeah, add and then we'll divide by 2. So add 2. So we'd add 2x squared equals 8, then dividing by 2. So I had x squared equals 4. We've been here before. Think about just to get the x, we would do what? Square root. And when I square root, I have to have what in front of it? Plus or minus. So we know x should be equal to plus or minus what? 2. Good. So you could write it as x equals plus or minus 2. Or you could write x equals 2, x equals -2. Either or works. So let's check out question 3. We'll look at like the left side, and then you guys can try the right side. So what would our first step be kind of with question 3? Yeah, divide by 16. So if we're dividing both sides by 16, we have x squared is equal to 9 over 16. And then we're doing what to both sides? Square root. And when I square root, number plus or minus. So let's think. X is going to be equal to plus or minus what? Good, 3 over 4. So if you needed an extra step here, remember it's like the square root of 9 over the square root of 16. All right, so let's check out question 5. So I have that binomial squared I want to get by itself. So think, this is what I want to get by itself. So what am I doing first to make that happen? What would we do first? Yeah, add 4. So I would have x minus 2 all squared equals 4. So now that you're here, now you can take the square root of both sides because I just have this binomial squared by itself. So taking the square root, I'm physically writing it in, which means I have to do what? Plus minus, good. So I have x minus 2 is equal to plus or minus 2. So what are we doing next from here? Adding 2. So think about when you're adding 2 at this step here. You want to get in the habit of putting that in front of your plus or minus. Just because when you're formatting later on, that's just kind of like the more acceptable form you like things in. So this is going to be x is equal to 2 plus or minus 2. So let's think, if this was a radical here, like if that was root 2, like the square root of 2, I can't combine those, right? But I can keep combining these to figure out what it's equal to. So let's think. X would be equal to 2 plus 2, which would give us 4, and x is also equal to 2 minus 2, which is 0. So remember, this is solving. So what can you always do to check to make sure you're right? Plug it back in. Oh, that's another good idea. Another good idea would be to graph it. Think about it's equal to what? 0, which is like being equal to, what did we talk about? That's like the same thing as. No, it's like, remember when you're equal to 0, remember that's like the same thing as being like y equals. So this could be, if I wanted to check graphically, I would plug it in to like my calculator or think about the graph as being y equals x minus 2 squared minus 4. But just checking really quickly by plugging in, if your x is 4, 4 minus 2 would be 2, 2 squared is 4, 4 minus 4 is 0. Same thing with 0, 0 minus 2 is negative 2. Negative 2 squared is 4, 4 minus 4 is 0, so that works. Good check. So let's check out number 7. So what's our first step in number 7? Good, so that goes sides by negative 4. So I'm going to have x squared is equal to what?
Plus or minus radical.
So negative 16. And then our next step is to take our square root. And remember, taking our square root, we have to include that plus or minus. So x is going to be equal to plus or minus what? Not just 4, but 4i, right? So don't forget, you might have imaginary values here too.
That equals -2.
Yeah, good. So thinking about what does that mean graphically? Do you touch your x-axis? No, you do not. So for these next 4 problems, so you guys try the right side for like the next 5 minutes. If you finish the right side early, start looking at the factoring, solving by factoring. That should be a review from Algebra 1. So for number 2, who wants to help us out what they got for number 2? Charlie, what'd you get?
You want me to like explain?
Nope, just say the answer.
Oh, 5.
Plus or minus 5. There you go.
Okay.
So, number 4, who wants to help us out and tell us what they got for number 4? Aubrey, what'd you get?
Plus or minus 2
Plus or minus.
radical 5.
Good job. So remember, you should reduce that radical. Don't forget. So number 6, there are some questions on that one. So just to kind of think, you should have x plus 2 squared equals 5. You're taking the square root, remember, with your plus or minus. So you have x plus 2 is equal to plus or minus root 5. So at this point right here, remember, you're subtracting 2 on both sides. So your answer should be this negative 2 is going to kind of squeak in before that plus or minus. So it should be negative 2 plus or minus square root 5. And then lastly for 8, what did we get? X to equal plus or minus, 1/3 I or I over 3, however you wrote it, works.
Yeah.
Yes. So if you got 2i over 6, remember you should have kept simplifying that too. Alright, so let's keep moving on to solving by factoring. This should be a review from your Algebra 1, so if you need a little refresher, remember, you set each factor equal to 0 and solve. Think about, we always want it equal to 0 because that's where what is happening graphically. Where is something equal to 0? It's on the x-axis. Good. So this is helping you find your x-intercepts. So you just set each factor equal to 0 and then solve from there. So we know 1, x should equal what?
-3.
-3, and then we also know x should equal 1/2. So think about what are those? Those are your solutions, your x-intercepts. So think about if you don't really know, you know at -3, you have 1, and then at 1/2, you have another. This is kind of what your graph is looking like, something like that. So 2 things from our quiz. One, we all, our number 1 thing was also forgetting that GCF. So let's look at number 3, and what should we notice and factor out first in number 3? 3. So kind of thinking back from our quiz, we should have 3x squared plus 2x minus 15 equals 0. So some of us factoring would just stop here, but we shouldn't stop. We should think, can we keep factoring?
Yes.
Yeah, so that would become x plus 5 and x minus 3. So that was just, and remember when you're taking out your GCF, so this is kind of relating it back to the quiz, remember you're bringing down that GCF of 3. But when I'm solving, so now switching gears into solving, I'm just thinking about setting my factors. So the factors like your parentheses with like your x inside of it. So I'm thinking about my factor x plus 5, making that equal to 0. And then my factor x minus 3, setting that equal to 0. So I know x should equal -5 and x should equal 3. Right, so why does the 3 not matter? It does not have an x with it for you to solve for. So, good question. So let's talk about when does having that like GCF, when does having your GCF, when would that matter? So let's look at number 2. So what do you notice first about number 2 compared to 1 and 3? 1 and 3 were equal to what? 0. What is 2 not equal to? It's not equal to 0. So your first step is always making it equal to what? 0. Think about why we're doing that. That's telling us where is it going to hit your x-axis. So making that equal to 0, you would have 6x squared plus 4x equals 0. So same idea here. Do we have a GCF? Yeah, good job. 2x. So I factor out 2x, then we have 3x plus 2 equals 0. So here's where your GCF matters. Why does our GCF matter here? Because it has an x with it. So one factor is actually going to be 2x equaling 0 that I'm solving for. And my other factor would be 3x plus 2 equals 0. So I know x should equal what first? 0, and then x also equals -2/3. Good. So why don't you guys take like 5 minutes, finish the rest of those 3 problems. Make sure it's always equal to what first? 0. And if you finish early, start looking at the next page too. So for number 2, you should have factored out your GCF of 2 and then got an x plus 6 and x minus 6 equals 0. So what do we know x should equal?
6 and
Yeah, 6 and -6. So looking at number 4, so when you factored, you should have gotten x plus 3. You move your 9 over, so it's x squared plus 6x plus 9 equals 0. So you should have gotten x plus 3 squared. So think about that's equal to 0. And you should have found x to just equal what? -3. So let's talk about what that means. So how many, we only had one solution, which means our graph, what does that mean graphically? It only meets on your x-axis where? At -3, and it only hits it one time. So what point is right here at -3? What was that? The vertex. Yeah, the vertex is right here at -3. Think about how can you tell about that graphically. Think about equal to 0 is the same thing as equal to y. So this is like y equals x plus 3 squared. What does this transformation say? Go left 3. Did I go left 3? Yeah, see? So thinking about how there's kind of going to be more than one way you can really figure out a problem and solve it or think about it. So just kind of keep thinking about the connections between the multiple representations that you are going to see. So number 6, you should have had a GCF of 2. And then from there, what were your factors? Like x plus, what was it, Luke?
So after simplifying out of it, you had 3x minus 1 and then x plus 6.
That sounds good. So we know x should have equaled 1/3 and what else? There we go. So that should be a review from Algebra 1. But let's keep moving and talking about solving with completing the square. So completing the square is a skill we've already kind of covered so far this unit. But let's talk about it in terms of solving. So when we were talking about it before, remember we would group our x squared and our x term together, and that constant term we would kind of like throw it outside of the parentheses and not really worry about it. We're going to do the same idea here. We're going to always group our x squared and that bx term together, and then that constant term we're always going to put it to the other side of our equal sign, just so we can complete the square with just that x squared and that bx value. So thinking about from here, looking at question 1, I have my x squared on the left. I also want my x term to be on the left, so I'll have to subtract 6x on both sides. I want the 2 to move to the right side, so we'll also have to subtract 2. So it would look like x squared minus 6x is equal to 2. So that's kind of your first step, getting it to have your x squared and your x on one side, and then just that number term, the constant, on the other. So now you want to think about what? What do I want to notice here? Did you have a coefficient in front of your x squared term? Well, just other than 1. So we only have a coefficient of 1 here, so we're good. So thinking about our next step is we're going to write this as a binomial squared. So we're going to complete the square just like we've been doing. So think about it, taking half of -6 to give us -3 inside. So reminding us from here, if I have, I'll do -3 and I will square it to add what? Add 9. So before, if we added 9, we also subtracted 9 because that's when it was all together, right? It was keeping that balanced. But now I have an equal sign. So if I added 9 on the left, what do I add? 9 on the right. So it's all about staying balanced. So if I was adding 9 on the left, I have to add 9 on the right, keeping it the same, keeping it balanced. Before, I added and subtracted on the same side. That's why we were doing that before. So let's remind us, this right here is the same as x minus 3 all squared. And that should be equal to what now? 11. So now, it's just like problems we were doing before. How are we going to solve for x from here? So what would I do next? How do I get rid of the squared? Square root both sides. So when I square root, I have to remember that. Plus or minus. So we just have x minus 3 is equal to plus or minus square root 11. And then what's our last step? to add 3, and remember when we're adding 3, gonna add 3, make that positive 3 go in front of that plus or minus. So x will be equal to that positive 3 plus or minus square root 11. So do we want to refresh our when we had that coefficient term? So let's look at number 3 together then. So let's think. I want my x squared and my x on one side together, and then my constant on the other. So I'll subtract 8x and then add 1. And then I'm going to also write it with my x terms on the left just because I like the look of that better. So what do we notice about our x squared term? What do you notice about the x squared term? It has a coefficient other than 1. So remember what we're doing, we're factoring out that coefficient, not the GCF, just the coefficient. So inside I'd have x squared minus 2x equals 1. So it's going to look something like this eventually. So let's talk about our next steps from here. I'm taking half of negative 2 to put inside that binomial squared. So half of negative 2 would be that minus 1. So this negative 1, I added it to move it to the other side. So I want the constant term on the other side from your x terms. So that was just me rewriting the equation. So let's talk about what's next from here. I took half of negative 2 to get the negative 1 inside that parentheses. Next, what am I doing? I'm doing negative 1 squared, which is positive 1, right? So right here, we're really adding 1. Hold on a sec. Remember, you had to pause because and think. I had a 4 all the way out here that I factored out. So I didn't really add 1. I really added 4 times 1, which is 4. So if you want to like a kind of a clear, like an extra step or just kind of make sure you don't miss a beat, remember you're doing, oh, I'm really adding 4 times 1. Kind of think about check here every time outside. Be like, oh, that would just be 1. Or like in the first example, oh, that would have just been 1 times 9. Here it's 4 times 1. So I'm adding that 4 times 1 here, which is really 4. So 1 plus 4 would give us equaling to 5. So now you still have one more step to get that binomial squared by itself by doing what? Good, dividing both sides by 4. So x minus 1 squared is equal to 5 over 4. And what are we doing to solve next? Square root. Remember, square root with that plus or minus. So x minus 1 will be equal to plus or minus. Think about that'll become the square root of 5 over what? 2. And then what's finally our last step? To get rid of that minus 1. Good, add 1. So it would be x is equal to positive 1 plus or minus square root of 5 over 2. So you guys have like 10 minutes left in class, so work on finishing those problems for the last 10 minutes. If you need any help, definitely let me know.